Welcome to the second video for chapter 13. It's comparing two proportions, and it's pretty much going to be what you know about one proportion just with two different populations. There's a couple little twists, but nothing major. All right, so again, you're going to have two population parameters, you're going to have two p-hats, you're going to have two sample sizes, you're just going to have two of everything. So first we have confidence intervals. So for confidence intervals, you are going to just have, this is the difference of your two samples plus or minus your Z critical value based on your confidence level, like we've been doing all along. And then the standard error. Now the standard error is a little more complicated because we have two populations. So we do the first population, the p-hat times 1 minus p-hat over n and square rooted. Then you have the second population, but we do the square root after we add those two numbers together. Then for the checks, you're going to do SRS, normality, independence. You're going to do all of that just for each one twice. Now, the only thing from this is we now do at least 10. That's been more of the standard than the 5 from now on. All right, so confidence interval, and there's a 2 prop Z int in your calculator. I will show you in a minute. Now with significance tests, just like we were talking about how we always assume the null is true until proven otherwise, that goes into this formula. So the null hypothesis is almost always one proportion equals the other. And until we know otherwise, we're going to assume that's true. So therefore, to figure out the standard error, we can combine the two values. And that's what the p-hat sub c means. It means the combined values. So let's say we had two samples. And let's just do this. The sample of 1, we had 10 successes. Sample of 2, we had 20 successes. The sample size we'll just say is 100 and then 150. So to combine them, we would just add the x's to get 30 and add the n's to get 250. So our combined proportions for successes would be 30 over 25. And then on the calculator under stat test, you just have your 2 prop Z test and your 2 prop intervals. All right, so we're going to type this into our calculator. We're going to go to a 2 prop Z test, and this is going to be our successes, and then that's going to be our n value. So see if you can find the place to put this into your calculator, and then we'll come back. All right, welcome back. Hopefully you found the correct button. If you have not, you press stat and then you go over to test and we go down to 2 prop Z test. You're going to put in your successes in your X values and then the total sample size, which was the 300 and 500, not the no's. And then our alternative is that they're not equal. So we're going to calculate. And so you get your z-score. The first p is what's called the p-value. So that's the p-value we've been using to reject or fail to reject the null. Then we have our proportion, our p-hat for the first sample, for the second sample, and the p-hat without any subscript, that's the combined p-hat when you add the x's and the n's together. So we'll go back to the finish up that test in 1 second. I just want to show you on the formula sheet where you would find this stuff. So from our other video, you have the sampling error for the two means down here, and above that you have the proportions. So we have, this is the one right here. This you would use when you're doing the confidence intervals, and this is the one you would use for hypothesis tests because you assume that the proportions are equal until you know otherwise. And it tells you right below it also how to do the combine, add your x's and your n's. So it actually tells you the whole process right there. All right, so let's finish up this slide deck. All right, so there's the numbers. So we have the hypothesis. Again, you can define the p, what the p sub 1's mean above, and p sub 2 if you want, or you can write it next to each thing. And then the conditions, You have it for both populations, check the sampling for both. And then the calculations, it's just showing the formula, substituting in, and then showing the p-value you get and the same interpretation we've been doing the whole time. So on this one, we would reject the null because the p-value is less than the alpha value. And then if you wanted to do a confidence interval, you could on this one as well. And you will see that 0 is not in this confidence interval. It's down here somewhere. So again, that reinforces you could reject the null. And again, that only works if your alternative is a not equals to. If it was a less than or greater than, it's not a one-to-one comparison, the confidence interval and the hypothesis test. And the type 1, type 2 errors, again, they mean the same thing as before. Type 1 is when you falsely reject the null, and type 2 is when you falsely fail to reject the null. So just depending on the context, you would interpret them the same way. All right, that is the end of chapter 13.